Welcome to Calc Center, home of the lowest budget ESPN site.
It is currently 4 a.m. Eastern Time, so to all our night owls, also math enthusiasts, welcome to probably the shortest running show ever in ESPN history. We have the top 6 calculus-driven plays
of this sports era. This sports
era. A lot of sports.
Yeah, sports.
First disclaimer: we have never seen any of these clips before. These are absolutely shocking athletic displays of math-driven plays. Here we have a Usain Leo Bolt clip running in lane 4, the Jamaican with the 9-time gold medalist.
Oh, look at him go. Look at him go. He's showing absolute dominance on the track.
Absolutely destroying the competition.
Yeah, exactly. Now, he finishes with a new world record. What's that time there?
9.58 seconds. Now, this is the amazing thing. Let's
look at the graph of his position.
This is the calculus behind this run.
All right, so we have the position graph relative to time. Now, all right, we see that's clearly exponential. Clearly.
Now we take the derivative.
This is the amazing part.
We take the derivative. We have the velocity. Guess what the velocity is? Guess what kind of function?
Since the distance is exponential, that means velocity is linear, obviously.
Now,
isn't that amazing? You take the derivative of position and you get velocity.
That's a direct relationship. It's a direct relationship between velocity and time.
Yeah.
That's unbelievable.
Mm-hmm.
Great run by our friend Usain Bolt right there. Here we got a LeBron James clip. Oh my God! Biggest stage of the sport, NBA Finals.
Absolute dominance on the court right now.
Unbelievable. Wow.
Look at him go.
Look at that. Yeah. Let's take a closer look here. Eric, let's get some analysis on this.
All right, you see him? Stop it down. He's not even near.
He's not even close.
He's increasing his speed.
Wow.
Increasing his speed. All right, let me talk to you more about his acceleration.
Yeah.
All right. Let's watch one more.
Oh my God! Wait, let's take one more look.
Every single time you watch it, it just gets better.
Oh my! Wait, one more look. It's slow mo.
Wow!
Wow!
Let's look at a deeper level. Let me draw this distance for you. So we have velocity, once again, relative to time.
Mm-hmm.
Now, what do you think? He's increasing his speed. So we're gonna say
at a constant rate.
So
it's
constant.
Constant right there. Yeah. Okay.
All right. Now, once again, we're gonna do something amazing. Derivative. Take the derivative of the velocity graph. What are we gonna get?
Acceleration.
Wait. Let me.
Yep.
Relative to time.
Yep. Acceleration. I knew it. Yep.
But now, since he's increasing at a constant speed, that's key. That means his acceleration is constant. Constant, straight line, boom. Derivatives are awesome.
Here we got a Michael Phelps clip, probably the greatest swimmer of all time. He had a little drug scandal back in 2009, but I'm not faulting him for that. Like, he's still great in my book. Anyway, he's moving to the right now. We got positive velocity, and with that, we've also got distance traveled is increasing, as well as displacement is increasing.
Oh, he's hitting the end of the pool. Is the race about to be
50
over?
meters.
They're going around. All right, they're heading to the left.
They flipped over in the water.
Their velocity is now negative, and their displacement is just decreasing every single second.
Distance traveled, though, still going up.
Still going up, distance travel.
I think this is a 100-meter race, but a zero displacement meter race.
Really all right, I don't get this. They're doing this race, but they're going nowhere. I don't get it. Swimming's stupid, in my opinion. But anyway,
why not just run there?
Just make the pool double the length. I don't know.
I'm proud of Michael Phelps, though. Go America.
Number 1, pretty amazing. Go
That's his mom right there.
Oh, she's crying. I don't know why. Oh, he's breathing. Oh, underwater.
Is he a fish? All right, here we have a golf clip of Tiger Woods. He is shooting the ball towards the hole. It's curved for some reason. And, he hasn't made it. It stopped. Oh, wow. He's done it. That's pretty impressive.
All right. So let's just take a look at the math behind it. All right, let me pull up some graphs for you and draw it. All right, so first we have the acceleration of the ball with respect to time, obviously.
Of course,
and so it's going to start off with a positive acceleration, decreasing, and then eventually negative. And now if we go down to the exact same time where it reaches 0, we're going to look at the velocity graph. Obviously, once again, with respect to time.
Of course.
All right, so we have this velocity. Sorry, it got cut off a little bit, but all right, so velocity is increasing as acceleration is still positive, and then once it reaches that top point, acceleration is 0. It's immediately going to start heading down to negative. Motion along the line, perfect in this respect. As soon as acceleration goes positive, negative, it's just going to start to level off and go back down.
Yeah,
decreasing.
and that's a max velocity.
Max velocity.
Where
exactly
the acceleration switches from positive
to
to
negative.
negative, that's a max velocity.
Derivatives are amazing, man.
I mean, it seems like derivatives are driving
the world.
We are at number 2 with Eli Manning starting off the clip, and it's a great throw by now a terrible quarterback, but it's a great throw to a great wide receiver, Odell Beckham Jr.
Golazo.
That's a great home run right
exactly, amazing.
So he hits it with a nice dance, right?
But I think we need to concentrate more on the speed.
Yes.
Look at him. He's starting off. He's increasing. I wouldn't say it's linear. It's some type of increasing, though. So let's look at the graph.
I would agree with that.
Yeah. All right. So
let's take a peek at this graph.
This graph, all right? Let's take it out. All right. So we have velocity on the y-axis, time on the x-axis.
Obviously,
recurring theme.
Obviously
time.
Obviously, he begins at 0 before the play starts. Here's the line of scrimmage.
He's increasing, like we said, and then we said reached a max speed of about 14 miles per hour, probably.
Yes. I'd say so.
All right. So because this graph is continuous and differentiable, but just by the looks of it,
over the interval 0 to 14,
of course. Yeah. I'm not going anywhere beyond there.
Yeah.
You know, at some point he has to reach 7 miles per hour. Why? Because of the mean value theorem. Obviously,
he could reach 10,
but
8.31.
In order to get from zero when he started to 14, you had to reach pretty much every single number in between there, including 8.329.
Yeah, C equals 8.
Mean value theorem, one of my favorites.
One of my top 10 theorems. Here we see a football clip. Oh my word. He has really stuck that one in the top corner. We are looking at Cristiano Ronaldo. He had a good stint at Manchester United in the Premier League. This one is an absolute firecracker. I would describe it as no less.
Now let's look at the graphs on this, right?
Let's look at what are we talking about? Rolle's theorem right now?
Yeah, Rolle's theorem. So the ball started at 0 velocity, right? 0 miles per hour. Once it hit the back of the net, once again at 0 miles per hour.
I can concur.
And then, because it started and ended at the same point, somewhere in between there, the derivative must be equal to 0.
The first derivative must be equal to 0, which means, because this is the velocity graph, that at the max point of velocity, the acceleration must also be 0.
And like you said, where this acceleration is equal to 0, it is the max velocity, which is totally amazing. Yes. This is one stationary point, as one might see it. Stationary point. And the definition. Definitionary. Because that's a word.
Oi.
Yeah. Crazy. Derivatives do it once again. Never fail to amaze us, derivatives.
Never fail to amaze us. Thank you for watching the first and probably the last Calc Center, as we received no funding, and this show will probably get shut down because no one's watching because it's 4 a.m.
And yeah, once the producers see this, they're going to be like,
yeah,
it's not going to work.
I don't know.
But thanks. We enjoyed it.
There's a reason there's no math shows on TV. Yeah. I mean, they're not
People
exciting.
Just don't like it.
We tried to make it exciting, but I mean, it got a little crazy at some point.
I would call it 100%, to be honest.
100 what?
Actually, 95. I'll take a 95%.
Yeah, I'd take a 95. Maybe
no less than a
90. Maybe a 71 with test corrections.
Test corrections.
Yeah.
No, definitely no lower than a 90.
Yeah, but like with test corrections.
Thank you, and peace out.
Bye.